So the last question. The graph below shows the cumulative percentage frequency curves of two normal distributions, M and N. The cumulative percentage frequency is equals to the cumulative frequency over the total frequency times 100%. It is given that the two curves intersect when the cumulative percentage frequency are both 50%. Which of the following are true? Okay, to easier explain, look at the horizontal axis right here. It is the variable is x. I don't want to use x because it is too hard to explain. I will use an example, maybe marks people get in two different classes. So we have class M and class N. So different students in class M and class N has got different marks. Okay, let's draw a line where they intersect. Maybe let's say this is 50 marks, so the passing mark of the test. The mean of the M is equals to the mean of N. Okay, in normal distributions, mean is equals to the median. And let's check their medians. 50%. The median is where 50% of the datum passed through has passed a certain amount of marks. So 50% of people in class M has passed, and also 50% of people in class N has passed. So their median should be the same, which is the passing mark. Therefore, their mean is also the same. So 1 is correct. Number 2, the standard deviation is smaller than the standard of M is class M is smaller than the standard deviation of class N. So we change it. I don't want A and B. I want, maybe let's say 40 here and 35 for 35 is for 16% people in class N has passed 35 marks. So the standard deviation of how can we consider the standard deviation is we look at the whole set of datum. If the data is the set of data is more converged, then the standard deviation of the set of data will be smaller. So around 34% of people in class N scored around 35 to 50, and around 34%, so the same percentage of people in class M scored around 40 to 50. So people you can think some people may fail in the test in class M, but even if they fail, they are not very far from the passing grade, which is 50. And if people in class N, maybe they get a 35, which is a little bit far away from the passing grade. So we can conclude that the set of data M is more concentrated than N. So the standard deviation of M should be less than the standard deviation of N. So statement number 2 is also correct. Statement number 3. Okay, we don't want 35 and 40 in this question. We want our A and B back. So for this statement, the standard score of a datum A in N is smaller than the standard score of a datum B in M. So a datum B in M, which means he has passed 16% of the, so he has outscored 16% of people in class M. So outscoring 16% of people in class M. And point A is, which means outscoring 16% of people in class N. So in different classes, the even A and B are different marks. They have outscored the same percentage of people in the class. And if we take a look back, it is a normal distribution. That means the standard score in the standard score of a datum A in N should be, instead of smaller than, should be equals to the standard score of a datum B in M, because they outscored the same percentage of people in the class. So the statement number 3 is wrong. They should be equal. So the answer is A.